Thursday's class. I think it'll be available.
So we have like 1 day to do it.
You have from Tuesday to Friday to do the stuff on the material we're going to go over today. This will be.
Yeah, if we had 1 day.
I'll go through it. Don't worry. We'll jump off that bridge in a minute.
Wait, I know.
This is quiz 1 take home. It's going to be assigned 20 to be tomorrow. Which it's already on. Yeah, you can take it now.
Okay, now I guess it's time. Good afternoon.
Good afternoon.
All right, so a few things to go through as far as like course administration. So the homework for section 2.1 has been up for a while. That's going to be due Wednesday. That's the stuff on categorical variables. So hopefully everyone's been working on that. The material that we're going to go over today, the homework will open up after class. It'll be due on Friday. Okay, so that'll be on making plots. There'll be a late due date, and then it's 50% on whatever you didn't turn in. And everything is through my stat lab from now on, right? No more turned in homework. Any questions on the homework? Yes, sir.
That is the homework for number 2 due Wednesday.
That's right.
So that's September 20th then.
Oh, thanks. Okay. Yeah,
And it says online, it says it's due tonight.
Um,
Can that change? I mean, like for tomorrow.
I can change that. Yeah, I probably wanted to do that. I always like you to have a class to ask questions. So yeah, I'll change that. Thanks. The quiz. You guys don't care about the quiz? Everyone's good about the quiz? I don't care about the quiz. Okay, so quiz 1. We'll have a take-home part, which I've already assigned. The data set's online. It's going to be very much like the take-home part of the exam, which is going to form 75% of each exam score. So the take-home is going to be based half on just knowing how to do the basic stat crunch procedures. It's going to be based a lot on interpretation, okay? Things that we've talked about but maybe aren't explicitly in the notes. You're synthesizing things. There will be an in-class quiz on Thursday. It'll be very brief. It'll be less than 15 minutes. 5 to 10 questions, mostly multiple choice. Just testing if you know things like the big picture, if you can identify different types of data, if you know the different sampling methods, if you understand context, and you understand the basic sorts of plots. So they'll be really very much conceptual. So the in-class tests the concepts, the take-home tests practice. That's the idea. Any questions on that part? Okay. So the take-home is already posted. Feel free to ask questions, okay? This is for you to think about and everything, and it's really practice for the exam. All right. One thing I want to mention real quick. Yes, sir?
For homework 1, are we going to get those back, or are we just going to go over the class?
I am going to pass those back. I'm still collecting them right now. So I'm going to go ahead and, in fact, you read my mind, because I want to talk about homework 1. I'll pass it back at the end of class, but I want to talk about the context, okay? So this was a bright student who wrote down what I said, okay, about the different questions. This is a great chart to have because there was a fair amount of confusion about the questions. The population of interest is not the people who are interested in the study. It's the group of people to whom the results pertain to. It's the biggest group of people that you can generalize the results to. That's important. The who is not who is conducting the study. We don't care who's conducting the study. It's totally irrelevant. Whether you're conducting it or Professor Harvard is conducting it is totally irrelevant. All I care about is whether or not it's done correctly. The who is the people in the sample. Okay? The what is what you're measuring. If you remember these questions, there's kind of a pattern, right? What was the data taken on? Who are the data taken from? Who was the data collected? Why was the data collected? Where was the data collected? How was the data collected? Everything about the data. That's all we care about. I'm going to actually post this because this is such a nice little chart. I really like this. And you'd be wise if you had problems when I hand this back with the context to look at that and really kind of meditate on that. It's very nice. Any questions on context right now? Okay. So let's kind of talk about why context is important, all right? I want to look at the notes for today. And the reason why context is important is it goes to this big picture. It explains everything we're doing. So what do we do first? There's actually a 0th step. The 0th step is we start with a question. The question is the why. Right? Why are we doing this? That's one of the context questions. The data collection is the who. It's basically everything else, but mostly it's the who and it's the what. I want to know who is in the sample, and I want to know what you're measuring. I want to know those two things, okay? The how helps, but those are why. How many people here have had statistics and done hypothesis tests as part of the game? Anybody? One person? No one else has had statistics? Okay. Hypothesis tests are not fun. They're the hardest part of the class. They're going to comprise easily half of this class. One of the hard parts is that you have to be able to put together all these pieces of information in the beginning. You have to know the why. Those are all relevant to hypothesis tests. Why you're collecting the data, what you're looking at, and who the data is from. Those are all 3 fundamental questions. And so this is going to be vital later on. It's not because I have a fixation on this picture. It's because this picture, everything goes together. The end is totally connected with everything before. And it's actually cyclical. Because after you get done with the study, what happens? You have new questions. And the cycle starts all over again. That's called research. Okay. So we've been talking about summarizing data. Okay. So here's where we are today. We're talking about quantitative data. What do? We look, plot, describe the plot. So we're talking about concepts that you want to know for the exam. That's an extremely fundamental concept. No matter what data set, what type it is, where it comes from, what day of the week it's collected, we always do this. Look at the data, plot it, describe the plot. Okay. And what we're going to see is that for quantitative, there's a lot more variety. Notice for categorical, if you've been doing the homework, you notice that they're all kind of variations of the same thing. You're just taking the counts in each class and you're plotting it different ways. They're variations of the same thing. Okay? Quantitative, the plots are going to be very different, and you're going to have a lot more choices. We're going to talk about 3 of these today: the dot plot, stem and leaf, and histogram. I would like to talk about the box plot, but the way the book splits things up, it does the box plot at the end of the chapter for its own reason. So we're going to postpone doing the box plot. And then Thursday, we're going to start talking, Tuesday and Thursday, we're going to start talking about the center and the spread. Okay, so this is where we're headed. Any questions on anything at this point? Anything that doesn't make sense, or you're thinking, why are we doing this? This is a certain type of logic that you have to buy into. Now, a word that we're going to use, a very important word, is the word statistic. Statistic is a little hard to define, but basically it's anything that you derive from the data. And usually it's computed. It doesn't have to be. For example, the mode is a statistic. Okay? The mode is not computed, in a sense. It's the highest number, but we don't even have to report what the number is, okay? But it's anything computed from data. So there's statistics, and there's statistics. And they're 2 different things. Okay? The summary statistics are statistics that we're going to compute that are going to describe the plots. And that's why this is in blue. These are called summary statistics. They're important statistics. They summarize main features of the data. Okay? So we're going to have a summary statistic that's going to describe where the data is centered. We're going to have a summary statistic that's going to describe how spread out the data is. All right? So, you know, you hear this This is a statistician's joke. I'll tell you this real quick. So, you know, on the holidays, they always say, don't drink and drive and become a statistic. You can't become a statistic. You can become a data value, but you can't become a statistic. So if anyone tells you that, say, that's impossible. All right. So we're going to look at a problem from the book first, okay? And then I'm going to look at some real-life data sets. I'm going to try as much as possible to give you guys real-life data sets. So I talk a lot with people that are in the military, people that are in the Air Force here, and trying to get some data sets that are kind of relevant. But this is one from the book, okay? So the idea is you run a company, you specialize in computers, and you think, we're losing some of the market share. Maybe it's because we're not innovative, right? We don't have a sharp enough cover, or we don't have a good enough, webcam camera or whatever. So the first thing you wonder is, are we spending enough for innovation, right? Are we spending enough in R&D? So you want to look at other companies, and you want to see what they're doing to see if you're spending enough, okay? To kind of get an idea if you're keeping up, right? So what we're going to do is we're going to look at the percentage of the total budget that 50 computer companies spend on R&D, and then we're going to want to figure out what is a typical R&D, expenditure. Okay, we're going to do this today. So we're going to look at the data today, and then on Thursday we're going to try to figure out what does it mean to talk about a typical value from a data set. So let's go ahead and rate the StatCrunch. I think it'll really help. Even though I'm making a screencast today, when I venture away from the computer, my voice goes down. You might not hear everything, and it just kind of helps to see what somebody's doing. So let's go rate the StatCrunch. And here's something that's very helpful. I like this aspect of the book. Whenever you're working with a data set that deals with a problem in the book, they actually give you that data set right in StatCrunch, which is really nice. So here we is. And go to StatCrunch. And I'm not going to do what we normally do, right? Normally we go to open StatCrunch, but what I'm going to do is something a little different. I'm going to say view the data sets from your textbook. Let's go ahead and click on that, okay? And you're going to get a new window that's going to open up. And so for every chapter, it's going to list the data sets. You can click on that. It'll automatically load it. So we're in chapter 2. And notice how the data sets are kind of partitioned. So all of the data sets that are actually worked out in examples in the book, they're at the top. Okay? So we're going to click on R&D. And then all the data sets that are referred to in the exercises, those are going to be down below. So let's go ahead and click on R&D. And it should automatically open up in StatCrunch. Now, here's a helpful hint. Whenever we get data sets, like a take-home quiz, you're going to want to look at it. This data set doesn't have anything strange, right? Or does it? Let's take a look and see. What are these? These are the percentages of the budget spent on R&D. If I see a value of -3, is that going to cause alarm? Yeah. I shouldn't be seeing negative percentages, right? So if I look down here, well, notice it's kind of hard to really get a handle on it. Let's use StatCrunch to help us. Let's go to Stat and go to Summary Stats. That's what we were just talking about. And click on Columns. So what I'm going to do is I'm going to get some summary statistics for the data that's in this column, okay? I'm going to click on this. And here's what I'm going to do. I'm going to click on N for the sample size, hold down Control, and scroll down. And I'm going to find the max and the min. Because most likely that's going to tell me if I have weird values, right? If I have a value of -3, it's going to show up as the minimum data values. If I have a value of 98, that's going to show up also. Let's see what we get. So what do you think about those numbers? It says I have 50 data values The minimum is 5.2, the maximum is 13.5. Is there anything strange about those numbers, do you think? They look reasonable. It's saying the smallest was 5% on R&D, the highest is 13.5. If I had seen something like 95 or 60%, right, then I'd have to worry, is that an invalidative or is that, an outlier, okay? So sometimes the line is kind of a little blurry, but here that's pretty clear. So with a clear conscience, I can go ahead and start looking at the data. Now, the three ways we're going to look at: dot plot, stem and leaf, and histogram. The dot plot is different. What we're doing on the dot plot is we're plotting on the x-axis the actual value of the quantitative variable. On the y-axis, we're plotting the number of times that value occurs. It's like a bar plot where every single value is its own category, which is kind of a weird sort of thing. But it works for small data sets. So let's go ahead and do this in StatCrunch. We'll just do graph dot plot. So I'll do graph dot plot. Okay. Notice something really nice about all the plotting commands. They all have the same basic format, right? I'm going to go ahead. It's going to first ask me, what do you want to plot? I only have one choice. That's easy. And you can increase the point size. This will increase how big the dot is, okay? I'm not going to worry about that. But here's something that you do want to do, and this is important. Whenever you turn in any sort of plot for a quiz or an exam, you have to have the x-axis labeled, you have to have the y-axis labeled, and you need a title. The hallmark of a good graph is I should be able to look at the graph and know exactly what I'm looking at without you telling me anything. That's the idea behind a good graph. So the x-axis is going to be percentage spent on R&D, right? You could put percentage of total budget if you wanted to. The y-axis for a dot plot is always frequency. We don't have relative frequencies, and we don't have percentages for dot plots. It's totally nonsensical. Doesn't make sense. And I'm going to put R&D budgets for 50 computer companies. One more piece of advice. When you're describing the who, it's always a good idea to say how many people were in that sample. You're really describing the sample. So it's not a bad idea when you put the title to say how many computer companies. And there we go. There's our plot. Now, I want to, so let's look at this. There's 50 data points, right? So let's ask the question, how many companies spend more than 12% of their total budget on R&D? Okay, 3 out of 50, so we got what? 6%, right? So this is how we read this dot plot, right? Here's the companies that spend more than 12%. The number of them are 3. We have 3 dots, so there's 3 out of 50. Notice that a dot plot gets way too busy when you have a lot of data values. So dot plots are only useful for small data sets, okay? Let's go ahead and copy and paste this. This is something you're going to want to be able to do anyhow. So what you're going to do is go up to Options and click up here, okay? And click on Copy. You can do this a bunch of different ways. You can do save and save it as a JPEG. I like to make life easy. And all I'm going to do now is I'm going to right-click copy, just like you would text, right? I'm going to right-click. I'm going to say copy image. And then I'm going to go wherever I want to paste it and do paste. Okay. And notice when you do this, you might want to clean this up. What's bad about this plot is you have this huge y-axis. I might put this into Paint and crop it a little bit. I might just use this portion and bring that part of the graph down. Okay? But I'll let you play with it. And that's our dot plot. That's all there is to dot plots. Questions on dot plots? Pretty easy. Okay, so let's look at stem and leaf next. So here's kind of the idea. We're going to take the values now and we're going to kind of bin them together. In other words, do I actually care if a company spends 13.2 as opposed to 13.4? Probably not. So why don't I graph them so that, why don't I kind of bin them together so that all the companies that make 13% are together, okay? This is a very compact way of writing this data set. So this is my data set at the top. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data values. And what I'm doing is I'm organizing them in tens. So the common part, the stem here, is going to be the tens place. Just like a plant, right? The stem is the common part, and then the leaves come off. So what are the data values represented by the top row, do you think? Anyone want to take a stab? Yes?
Is it the top row?
Yep.
It's the frequency of 21, 24, 26, 27.
Exactly. This is a very compact way of writing. This is saying these are all the numbers that start off with 20. We have 21, 24 occurs twice, 26 occurs once, 27 occurs 2 times. Okay, so you can see that from that. So this is really nice. Notice a really nice advantage is that you get to preserve all the data. The dot plot does not show you the data. I get to actually see all the data. I'm not throwing anything away, okay? But it's very compact. I put that huge list of 10 numbers, and I have this nice little representation, okay? So this is called the stems place, which is a tens place. That's what I'm using to bin things. This is the leaf part. This is the ones place, okay? Let's go ahead and try this in StatCrunch. Now, you might be saying, how do I choose the stem and the leaf? That's a really good question. It can get tricky, but StatCrunch will try to do the best it can for you. So let's go ahead and try the same thing. Okay, so we'll go to Graph, Stem and Leaf, choose this. And I'm not going to specify the leaf unit. You can. And we'll play around with that, but for right now, let's leave it be. Because StatCrunch will do a really good job of guessing, okay? The only thing I'm going to do is I'm going to take off this outlier trimming. The outlier trimming, it would take off any really values that are extreme, but I want to leave everything in because I don't have any extreme values, okay? And I'm going to go ahead and say compute. So notice how different these 2 different plots are. These are 2 plots of the same thing. Okay. So, you know, different people, different strokes, different folks. I like this version a little bit better. Notice a nice thing about keeping the values. I said what my company was at like 7%. If I want to see how my company compares, I can directly see this in the plot, right? I can see the 70s or the 7% are there. And sure enough, 7% kind of at the low end. Okay? I can see how my value compares to everyone else because I can see all the values. So what is this value right here? The 13 and the 2. What is that value? It's 13 what? 13.2. And it tells you. It says the leaves are the tenths. Okay? The stem is going to be the ones, okay? How do we copy and paste that? Just like you're copy and pasting text, okay? So I'm going to click on options again and say copy. And just like this is a Word, a Word document, I'm going to go ahead and just copy and paste this like this. Notice that I can't really add axes on this very easily, can I? So this is kind of an exception to that rule. Sometimes when you want to paste it, it's a little easier to use a text box. I'm just going to open up a text box here. And for some reason, it does its own thing. I don't know why. Let's see. Here we go. Okay. So I'm going to have to be a little careful and kind of do this on my own. You can, of course, you can take a screenshot also, which might be a little easier. And this is my data. Be careful. There are no 12s. It's 113. And I'm going to blow this up a little bit. Make the font a little larger. Okay. So like I said, you may want to take a screenshot and paste it. Now, here's something really cool. I'm going to rotate this. So there's a little handle at the top here, right? You can rotate this. So what do you have? You have what looks like a plot now. You have basically a bar plot with all the data in it. That's really nice. It's nice to be able to see all the data and get something that looks like a bar plot. It tells you that there's a lot of companies. There aren't that many companies that have to only spend 5%. There's a fair amount that spend 6, 7, and 8. Then there are less companies that spend 10 or more. And if you want the exact details, you have the data right there too. So stem and leaf is really nice. But what if you had a huge data set? What if you had 1,000 data values? It would get to be a pain. So stem and leaf is kind of like dot plot. It doesn't work well with really big data sets. But for intermediate data sets, it's kind of nice. So here's kind of a nice rule that you might want to keep in mind. Really small data sets, dot plot. Intermediate data set, stem and leaf. Large data sets are going to be the next plot. Okay? So let's look at histograms. This is the last one we want to look at. Everyone getting the plots are looking good? Okay. And I will put up some videos from StatCrunch if you want to look at those. And I'm also making a screencast of today. So, okay, so with histogram, here's the idea. We don't plot the individual values. What we do instead is we do something a little bit like stem and leaf, except we lose the numbers. We say, okay, I don't really care if it's 13.2 or 13.4. Let's create little intervals, even intervals, and go ahead and count the number in each of those intervals. So you notice that here, I have 16 heights. I have a hypothetical data set of 16. And the heights go from 63 inches to 72 inches. There's a spread of 9. So I want to create these little bins, right? So what if I start at 62? Then the range of my data is 10, and I could put them in little bins of width of 2, right? So this is the idea. I'm binning these now, okay? So these are the number of values that are between 62 to 64. Is that right, though? See, I have 63 and 64. Shouldn't I have a 2 there? Should I have 1? What do you think? What's that?
The next bin goes from 64 to 66.
Yeah, so which one's 64 and why?
There's a bracket.
Right. So this is going back to algebra, right? This is how we represent intervals. So this interval right here, remember closed brackets means include that value, and open means don't include. So these are all the set of x. These are the values that are all between 62 and 64. Including 62, so we have the closed brackets, not including 64 because we have the open. We have to take care. We can't count one data value twice, right? That wouldn't be good. Right. We can't do that. So now this makes sense, right? Between 62 and 64, not counting 64, I have 1. And you can convince yourself if you go through the rest of this table that that's what we're doing. And then what do? Well, now we kind of treat this a little bit like categorical. I'm just gonna plot the number in each interval. So I have 1. Oh, but I'm not plotting 1. Am I? So remember when we said before with categorical, we only really plot percentage, right? Well, with quantitative, we usually plot relative frequencies. You can plot percentages too, but we generally plot relative frequencies. So this is the number in each interval divided by the total number. So I have 1, and I have 50 total. So this is going to be, this should be 5, hold on. This should be 2%. So what's going on? We have 1 in 50 or 2 in 100. So this should be 0.02. Let me see real quick. Let's go ahead and plot it. So we'll use histogram. And I think this was the plot I got from StatCrunch. Let me see. Oh, you know what? Hold on a second. Oh, I'm looking at a different example. I'm sorry. I told you I'm wonky today. I'm looking at this example. For this example, it's okay. I have 16 heights. I have 1 in 16, which is roughly 6%. Sorry. I was thinking of another data set. So this makes sense. Okay. 4 in 16, 25%. That's what I'm seeing. Under the whole curve, what did that have to add up to? All of these areas have to add up to what? 1. Right? This is telling me the relative frequency in each of these intervals. They all have to add up to 1. Okay? Sorry about that. Okay, questions about histograms? Everybody's good on making them? Now, one tricky part with stem and leaf and histograms is how to choose these stems and how to choose a number of bins. Let's go back to stem and leaf for 1 minute. So let me just illustrate this. We'll go back to graph. We'll do our stem and leaf. And choose this variable. And now I'm going to specify the leaf. So the leaf before was 0.1. Let's change it to 0.01 and see what happens. Take that off. Notice what happens. It looks really ugly. Okay. So the wrong choice. So this is 8.10. So notice that there are very few that differed in the hundreds place. This data set's really spread out. Okay. I really can't see very much. So the choice of the stem can be important. Usually StatCrunch does a good choice. Where it doesn't always do a good choice is with the histogram. That's where you have to be a little careful. Okay. So, and let's go ahead and let's go ahead and do the histogram for our problem here. I'm going to click on this. I'm going to do relative frequency. Oh, come on. Here we go. And finally, I'm going to put my table in. Percent budget spent on R&D. And now this is going to be relative frequency. And finally, we'll say all right. There we go. And we can leave everything else be. Okay. And there's what our plot looks like. 3 different plots. They look pretty different, okay? If we go back to and kind of compare them now. Okay, these are the 3 different plots. Probably the best of these 3 is the histogram. The dot plot is really kind of busy. And the problem is because we're making every value its own category, we're not really seeing any sort of trend, okay? Very often you'll plot a data set and every value will be so different, they'll all have a frequency of 1. And the only way you can really tell what's going on is you have to see how bunched up they are, right? So this is telling us there's a lot of values bunched up in here, but it's not giving us a good picture of what's really going on, all right? Let's go ahead and copy and paste this. And by the way, save this because we're going to come back and use this later on, okay? When we get done, we're going to save it. So we'll click on Options, and we can do Copy. Okay, and there we go. And there's our histogram. Now, one thing is a little tricky is how we create these bins. Notice that StatCrunch has done it for us, but StatCrunch doesn't always get the right number of bins. And it turns out the shape can be very, very dependent on how you choose the bins. Very sensitive, okay? There actually is a rule. There were two statisticians, Friedman and Diaconis, 1986, they actually made a rule. You can look that up. It's kind of a fun thing. StatCrunch uses that, but it's not always the best. So here's some guidelines that we can use, okay? One of the things we're going to start to pay attention to is whether or not our variable is discrete or continuous. That's going to have an effect on how we plot it. So when we look at discrete data, in other words, with discrete data, we're always talking about count data. When we're looking at count data, and we don't have a lot of values, like maybe 0, 1, 2, 3, okay? We always use an interval width of 1. And usually StatCrunch will do that for you, okay? When you have continuous data, you want at least 5 bins. There's theoretical reasons for that. We'll come back to in section 2.8. But the idea, the overall idea, suppose you said, I don't want to remember all these rules. That's fine. The idea is that you want to choose a number of bins so that the data is basically approximated by a nice smooth curve. You can see a nice smooth curve going through that plot. So this is the same data set plotted 3 different ways. Here we have 100 bins. It's kind of like the 3 little bears, okay? We have too many bins down here. How can we tell? The graph's very choppy. There's a lot of variation, right? So this is too many. The one at the top isn't bad, but it's kind of too few. It's a little too gross of a picture. If we play around and we do 25 bins, you'll see that I can see in my mind's eye a nice smooth curve going through there. What we're really trying to get is we're trying to get the plot of what it would look like for the population. And for the population, we'd have a whole lot of data points. And what would happen is we'd actually get a nice smooth curve. So if you went into the Daphne Islands and you looked at the finches and you measured all their beaks, okay, the data set would actually look like a nice smooth curve. And that's what we're trying to approximate. We're trying to figure out what does the population look like. The population's always a nice smooth curve. Who knows? You might play around, you might find something a little bit different, okay?
So it's just a bell curve.
No, it's not a bell curve, but it's a smooth curve. There's a lot of different shapes that the distributions can have. We're going to come back to that. Shape's actually a big thing. We're very much interested in the shape. Okay? But that's kind of one of the problems. Everyone's used to, a lot of what you've seen is like the bell-shaped curve, but there's a lot of things that are not bell-shaped curve. All right. And this may or may not be bell-shaped. It may be, but there's a tail here that makes me wonder about that. Okay. But here's the idea. The more data points you get, the more we fill in those little gaps, the better we could tell what it really looked like. Okay? That's the idea. I had a student last semester, it's kind of an interesting little story. We were looking at Porsche prices, the price of Porsche over different years. And the authors binned the data one way, and they came to one conclusion. I had a student who was very astute, and she liked to play around with the binning and actually figured out there were 2 different populations. There was a group of older cars, and there was a group of newer cars. And even the authors didn't see it. There were 3 good statisticians. So sometimes just playing around with the bin size, you can see some really cool things. Okay, so this comes down to what sort of plot we use, okay? So the first thing you notice is that we're making a difference between discrete and continuous. That's going to be important. When we have discrete data, which is always count data for our purposes, and we don't have a lot of values, we have maybe 3 to 5 values, we always use a histogram. If we have 2 values, we basically have a categorical variable. We really don't even have quantitative. We only have 2 categories, right? If we have a large number of data values, usually it's more than 20, somewhere in there, we always use histograms. And you can see, if you do that, if you do some of the data sets with stem and leaf, you're going to see that it's too busy. Okay, we have too many data values. Histogram is always the right answer. If it's in between, if you have discrete data and you have between 5 and 20 distinct bins, okay, data values, sorry. You have more than 5 to 20 distinct data values, I should say, all right? Then you have to play around. So if you looked at, for example, like the average number of students in a classroom, right? That number, at some colleges could be around 5 to 20 if you're at a really small school, okay? How would you plot that? Well, you'd have to play around, okay? When you have continuous data, for small data sets, we always use dot plot. When we have less than 10 data values, we always use dot plot. When we have between like 10 and 20, usually stem and leaf. When it's more than 20, it's kind of up in the air. When it's more than 30, it's always a histogram. Okay, kind of have these general rules. When in doubt, do all 3. They're easy to do, right? It doesn't cost you anything. Play with all 3. But these are usually pretty good rules of thumb. All right. The histograms, you may have to tweak the box size a little bit. You may have to play around with that. Okay, questions on plotting quantitative data? Why don't we do some? Let's go ahead and do some examples. So this is an example data set. Back a long time ago, the German army had mules. People got kicked in the head, kicked in the chest, they got killed by these mules. And somebody kept data for the Prussian army, okay? This guy, I won't even pronounce his name, between 1875 and 1894. And so we want to find out what is a typical number of deaths in a year, okay, due to these mule kicks. So we have a data set. Let me go ahead and open that up on modules. So if you go over to modules, let's see, data, Prussian Army mule kicks, hold on. Okay, you can go ahead and you can get that. So now it should be available. So if you refresh your screen, you should see it pop up now. And let's go ahead and take a look at it. Everybody seeing it? Everyone has it? Okay.
Oh, it's under chapter 1 data.
I think it should just be under data sets. I have them all together. Is that right?
It's under chapter 1.
Chapter 1, okay. Oh, I got to organize that. Thanks. Okay, there's my data set. I'm just going to save it to wherever I'm saving my data sets. So we'll just save as. Okay. And all right. We'll open this up in StatCrunch now. So go over to StatCrunch. And you can open up a new, if you want, you can actually just open up while you're in StatCrunch. You can just open up a new table there, yeah. But I'll just start from scratch. But if you make sure that you save this, the R&D, So go ahead and save this now. You can save this by going to, let me get out of here. When you go to StatCrunch, when you go to data, so go ahead and save that right now. Save the R&D, because we're going to use this later. And hold on a second. I don't want to do that. Yeah, I want to, hold on a second. What did I do? I think I want to download the session. Give me 1 second. Give me 1 second here. It is data.
Save.
It should be saved, but I should be able to save it as my, oh, you know what? I don't think it will let me save it as my data. That's okay. Let's just go ahead and save it. No, it is saved to my data folder. I was doing it the right way. Yeah, so go to save to my data, and do that. I didn't see my data. Yeah. And now that's saved permanently. Everything you've done, all the plots and everything are all saved to my data. When you come back into StatCrunch and you want to load something, you can go right to my data and do that. Okay, so let me go ahead though and open up our data file. And we'll load it. Okay. And there we are. All right. Now, we always want to know a couple of things. We want to know how many data values, and I also want to look at the range. I want to look at the maximum and the minimum, okay? So before I do anything, I'm going to make sure I understand what's going on. The first column is the regimen the data was taken from. And the second column is the number of deaths that were caused in that regimen by mule kicks. Okay, so we'll go to summary stats next. And I'm going to just look at deaths by mule kicks. And I'm just interested for right now in the sample size, the max, and the min. We're going to use more of these later on. I want to make sure I have an idea of how many data values there are. That's going to be important later on. And I also want to know if there's any weird data values. So 0 and 4 look okay. That's kind of what I would expect. I'm not seeing like 3.8. That would be kind of weird. Or 20, or -5. So the data set looks okay. Now, how do I determine what sort of plot I'm going to make? Well, I look and ask myself, what do I have? Do I have discrete or continuous? Do I have discrete or continuous? And the second thing I want to ask myself is, do I have a low number of data values, intermediate, or high? So these are the number of data values. And I had to be a little careful. Actually, these are the number of distinct data values. And maybe be careful. Distinct data values. It isn't the sample size. In other words, how many different values can that variable take on? All right. So mule kicks, is that discrete or deaths by mule kicks? Is that discrete or continuous? Discrete. It's count data. Definitely discrete. How many values do I have? I have 5 values. Right? 0, 1, 2, 3, 4. So this is a low number of values, discrete. I'm going to definitely use histogram. That's what that table's telling me. If I had discrete and intermediate, it's kind of a coin toss. If I had a high number, it would be histogram again. And by high, we mean what about 20? If I have 20 or more discrete values, okay? This is 5 or less. And anything in between, we have to play around. It just depends on the data set. Let's go ahead and make the histogram. So, go up here to Graph, Histogram, Deaths by Mule Kicks. I'm going to plot relative frequency. Okay. And the X label is going to be number of deaths, relative frequency, and this will be death rate in Prussian Army due to mule kicks. And you go ahead and hit compute. All right. And now we get a picture of what the data looks like. All those 280 values that you can't look at and make sense of, now I can make perfect sense. Okay? I see that over 50% of the regiments didn't have any deaths, about 35 had 1, maybe 12 had 2, 5% had 3, and 4 occurred very, very rarely. All right? Now, try it with stem and leaf, just for fun. See what you get. You'll get a really nasty plot. Try it with dot plot. It won't be as nice. Okay. Questions on the histogram on this data set? Okay, let's look at another data set. This is a data set that I collected from an Embry-Riddle student, actually. I'll let you fill in the blanks. So everyone here knows about the F-16, right? I don't tell you about it. It's been out for a long time, so they're kind of old. Problem with F-16 is there's a lot of accidents. So the Air Force, it classifies accidents. The worst accident is called Class A. That's when either the plane's totaled or the person's killed. So those are the worst, and they definitely keep track of that. And so there was a student, still is, he's doing a thesis on the Class A accidents of the F-16. So let's go ahead and take a look at that data set, see what they're like. Okay. He wanted to see whether or not there was a lot of accidents and then try to understand why. So I'm going to go back up to modules again. And let me open up the data set here. So it should be F-16 Class A accidents. Okay. And if you refresh modules, it should come up now. All right. So go ahead and click on that and open that up. And then you can save that. So if you look at the data set, it's not too big. There aren't that many years it's been out. So these are the years that they monitored the F-16, and these are the number of Class A accidents. And you can see that even though it's discrete, there's a really big range. Okay, so there's at least probably 30 some distinct values. So we might want to play around and try different ways. Okay, let's go ahead and load this in the StatCrunch here. Read the data in. Oh, interesting. I didn't save this apparently. And let's try histogram first. Let's go ahead and try the histogram first. I'm just going to load this and save this real quick. Okay. And there we go. Before we do that, let's go ahead, just to make sure, even though the data set looked okay, let's just real quick do the summary stats, okay? So let's look at the sample size. I'm interested in accidents here. Look at the sample size, the max and the min. So that's a pretty big range. I have what? I have 31 data values, the minimum 0, the maximum is 23. So, but they're not all unique. Some of them are repeated. So let's go ahead and let's try dot plot first. We can come back and add labels later. There's the dot plot. And we'll do the stem and leaf. There's the stem and leaf. And finally, we'll do the histogram. And there's the histogram. The dot plot, there are too many data values, okay? You really can't see much going on with a dot plot. It's very featureless, right? Here I can kind of see what's going on. This is the bad plot. Notice how it's plotting it. What is the stem here? The stem, now notice this goes from 0 to 4. This goes from 5 to 9, okay? So this is kind of an atypical sort of stem. It's breaking up the 10s into 5s, all right? It's doing the same thing here, right? It's binning the data in intervals of 5 and plotting it. Which one you like? Beauty is in the eye of the beholder, right? I like the histogram. I think the histogram's not bad. I have at least 5 bins. That's what I need, okay? And it looks good. It gives me a good picture of the data. I can see that there's a decent, I should do relative frequency actually. There's a decent number that have 0, then it kind of peaks a little bit, and there aren't a lot of really severe accidents, okay? All right, questions on any of that? All right, last data set. So, and so which one's the best? It's kind of up to you. I would say dot plot is definitely not in the running. I'd say it's between stem, and these are basically the same thing when you think about it. Stem and leaf and histogram are basically the same thing. They're really identical. The only difference is the stem and leaf is showing you the values that are in each of those bars, okay? So I might argue that this is the better one right here. Okay, last data set. We're going to look at Bitcoin. So everyone knows about Bitcoin. It's electronic currency, has a lot of advantages, okay? And the thing about Bitcoin is that it's really increased in value the last couple of years. So you might want to know, for example, is it a good idea to buy as an investment? Not because you're interested in actually using it, but just purely as an investment. So what I've done is I've collected a sample of the exchange rates in this past year. The year before that, the exchange rate was 456 bucks. We might want to know, is this past year a lot higher than 456? Let's go ahead and download this. So go to modules, and I'll open it up here. Okay, if you refresh your screen now, it should be there. And we'll go ahead and open that up and save that and then put it in StatCrunch. Yes, sir.
Oh, it's not showing up.
I'm sorry?
It's not showing up.
Let me see. So here's what I'm seeing. Let me make sure. So this should be open now. Is everyone else seeing it, or is it? Okay. When you refresh, are you seeing it now? That's strange. Okay. Let me take a look afterwards. Okay. We're gonna basically go through the exact same steps, though, right? I'm just gonna download it, and I can take a look later and see. So this data set has two columns. The first column is the timestamp. It's telling you the date that the data was collected. Yeah, let's see if I can get it to load here. For some reason, my computer is really slow today. Actually, I have it already stored. I'm just going to go to my copy. Okay. I'm going to open up a new screen. Okay. And we'll go ahead and load it. And let's get the sample size and the max and the min. Let's take a look at those. Takes a little while to load. Okay. And notice the sample size is huge. Okay, so this is a big data set. And most data sets are like this. Most data sets are really not that small. Okay. So open that. Now let's try dot plot first. With the exchange rates, it's kind of hard to know what you should see, right? Unless you're really, conversant with this sort of stuff. We go to summary stats. And the only thing I have is column 2 to look at. That's where the exchange rates are. Look at the sample size, the min and the max. Okay. And there we go. Okay. And nothing looks really crazy. I'm not seeing any values that are really off the wall, but I have 365 values I have for the whole year. So let's go ahead and try dot plot. And what we're going to see is that dot plot's going to be too busy, okay? We see a lot of buildup. We kind of get an idea where the values are, but I really can't draw a nice smooth curve. This is like a histogram with a bin size that's too small, right? So let's go ahead now. That's definitely out of the running, which we thought. Let's try stem and leaf and see what we get. And I should have taken off the outlier trimming. Notice again, this is even worse looking, okay? It's trying to bin the data, but you can see the problem. There are so many values in each of the bins that this is really not aesthetically nice to look at. You can't really get a picture of what's going on here, okay? Notice another deficiency of stem and leaf. You have to do the translation in your mind. You have to know where the stems and where the leaves are, okay? So this is a little bit of work. I have to go through here and realize that third line down is from 15, well actually the stem is the hundreds. So this is from the 1500s to, this is from 1000 to 1500. That's a little bit of work for your eye. So there's a price to pay for getting all the data values. All right, last but not least, the histogram. Okay. And this is going to look a lot nicer, a lot easier to understand. Okay. Notice that for real life data sets, a lot of data values, it's definitely the best plot. I would probably play around with this a little bit. I might try to make the bins a little bit wider. See if you can play around with the bin size. Make the bins a little bit wider, see what you get. Yeah?
Why is the graph at the bottom going 5,000?
I'm sorry?
Why is the graph at the bottom going by 1,000 for the x-axis?
These are the values, right? So here are the values that the Bitcoin exchange rate can take on. Okay? And then these are the numbers. So this is like from I don't know, maybe 500 to 1,000. And then this is saying that there's 140 days of the year when we had that price.
Oh, okay. Sorry, I didn't realize that they were going all the way to.
Yeah, exactly. That's why Bitcoin is so cool. So play around with the bin size. You can get a little bit better if you make the bins a little bit wider. Any questions on histograms, dot plots, stem and leaf? Okay, so a few things I want to leave you with. So when we describe a plot of quantitative data, there's 5 things we have to report. We have to report the number of modes, the shape, where the center is, how wide the data set is, and whether or not we see any outliers or unusual extreme values, okay? The number of modes is very easy to categorize. You can have no modes. In other words, the mode is the most commonly occurring value. Notice that the mode is an artifact of how you bin the data. If you bin the value differently, the mode will be in a different place. Okay? So here, you could have, when you have a situation where you have no modes, a uniform distribution is going to be like that. We call that uniform. When there's none that stand out. You have to be careful what you consider a peak. Okay? There's a lot of fluctuations in this graph. You might say, oh, I think that guy, the 4th bar over from the left is a peak. He's not. So it takes a little while to train your eye so you can notice that. So this is a peak. Okay? We have one mode here. That's called unimodal, like unicycle, right? Uni-1. Bimodal is where we have 2 distinct peaks. We don't have tri, quatra, or tetra. We just have multimodal. Why do we care about the modes? Because modes generally indicate subpopulations. If you're measuring the reaction time of a population where there's really young people and really old people, you're going to see bimodal. When you're looking at women and men, you very often see bimodal, okay, these sorts of bimodal distributions. And that's important because that's a factor that's affecting your results. You want to know about that, okay? So we always report the number of modes. We don't really care where they are per se, but we have to report the number. The shape is the next thing. We're going to see why the shape is important. So in statistics, it turns out that the shapes of these plots can't take a lot of arbitrary shapes. They're very, very general. You're either symmetric, which is in the middle, and symmetric is like a mirror symmetry, where in other words, I can cut it down the middle, and I have two equal halves. It won't be perfect, but it'll be close to being like that. If it isn't symmetric, it has a tail. And we have a name for a tail in statistics. We call that skew. And we report what side the tail is on. So here I have a tail, okay, on the left side. So we say it's left skew, or negatively skewed. Here I have a tail on the right side. I'm going to say that's positively skewed or right skewed. And the reason why we care about that, we're going to see next time that the shape of the plot determines how we describe the shape, how we describe the center, and how we describe the spread. We're going to see how we do that is going to depend on the shape. All right. I think that's all for today. Let me hand back the homeworks here. ¿Estás viendo? Very nice. Brandon Miller? Michael? Mr. Fang? Mr. Fang? Joshua Gordon? Can you just pass that down to Joshua? Angelica Gould? No, pass that down. Can you pass that down? William Locke? I think I say, given the price, I'm pretty sure.
That was due today.
Okay.
It's 5 questions.
Mr. Lee?
Right. Oh, I did it.
Alex Longo?
I got 97.5. I only missed like partial, like one some part of question 3.
Justin?
You missed. Oh, if you had multiple takes on multiple.
Oh no, I only did
Ms. Chavez?
one. And the one that I got wrong, I didn't get the previous one because it was a
3 questions. Yeah, that might be. Well, I don't know why.
Yeah, if you want to look back,
Whatever. More class.
Yeah, I'm trying to.
I saved you. Anthony Michelle? Yeah. I'm so excited. I have to go to and no Brandon Miller. So like you don't really. Okay. I'll hand back the rest on Thursday.
Can I have my paper?
Did you?
WNG.
Yeah, you did. You did turn it in. Here, let me.
I turned mine online, so
Yeah, I have yours. Hold on, I know I have yours. I don't think I handed them back off. Leah's gone. I don't know why I didn't.
Yes,
there you
Thank
go.
you.
Yeah, no problem.
I got a couple of questions to ask you, but we have to go to my laptop and a little bit later.
All right. I have yours. I printed it out because it was online. Let me. I have it right here. Actually. Yeah.
Your office is on the College of.
Arts and Sciences, third floor, right where the math department was. Yeah. All right, interesting paper.
But interesting. I don't know how to respond correctly. I don't know if I gauged it, but yeah, I'll be back. Well, I'll be back here. I just can't move my laptop. The battery's dead on it.
No problem. Take your time.
Did you put in the extra stuff yet or no?
No, I haven't had a chance to do that yet. Yeah, I will. Because the weird with Canvas, it's really hard to enter it. I have to technically enter it at the very end when everything is done, as far as I can tell. Because I have to enter it as points, not as a percentage. Mm-hmm. So it's a little weird. Okay. But I am keeping track. All right.
All right. Thanks.
Yes, sir. How can I help you?
So I need to save this all data.
Yes, please save each one of
Everything?
those. Well, each one you can save. If you go,
Okay, I save. I don't.
that's a good question. So if you go to data and you say save, Yeah, right there. And it'll automatically save it to my data. I didn't see that before. You want it to be saved to my data, so you can go ahead and
Just
name.
my
That's
data?
good. I think everything looks good there. You can keep it like that, and then you just say save. And then when you come back into StatCrunch, it'll have all that old work. You won't have to redo it all over again.
So how can I find if I save?
Good
Go to
question.
the data
Yeah, go to data,
and the data.
and you go to load
Yeah.
my data. Cool, huh?
Okay.
All right.
We have question for the homework.
Sure, sure.
We don't know how to find the population.
Right. So the population, what the population is. So think about your sample, right? And you have some results for your sample, okay? Like I say, okay, with the person walking in the football field, right? Based on my sample, nobody was able to go down the whole football field, right?
Yes, right.
Now I want to know what is the largest group of people that result applies to. Does it apply to people walking in the hallways here? No, right? It applies to people who are out in some sort of environment where they don't have visual clues. Okay? So the population is the largest set of people or individuals that you can generalize that result to. So you think of the sample as coming from the population, right?
Yes, right.
So what was that whole group of people that it came from?
From the football team, you mean?
In other words, like, okay, for example, so you're riding along your car tonight, right? And someone comes on the radio and says, if you eat, if you let me think of a good example. If you're older than 50 years and you eat a lot of red meat, there's a chance you'll die of a heart attack, right? Well, how did they do that? Well, they did that based on a study. They got a group of people that were over 50 years old, fed them red meat, found out they got heart disease, right?
Yes, right.
Based on that sample, the largest group of people that those results are relevant to, that it applies to, are people over 50 years old, right?
Yeah.
It doesn't apply to you necessarily, right?
Yeah.
That's the idea. We want to find the largest group that those results could. In other words, you could ask yourself, who could use that information? Who does that? What group of people would actually fall into that sort of situation? Okay. So here, for example, with the first one, this is a very general concept. This pertains to anybody who is involved in a transaction where there's an honor system in place, right?
Yes, right.
That's what's really going on. Although you could say it's coffee drinkers, that's fine. But really, it's actually looking and seeing, any group of people that's involved in a financial transaction where I'm trusting you, this could apply to, right?
Yes, right. All right.
Does that make sense?
Yes, yes.
Think about the other ones. I will post a solution key, and if my answers aren't making sense with what you think it should be, let me know, and we'll talk about it some more.
So
Okay?
for the Thursday quiz is similar to this question?
Yeah, it'll be just like that. It'll be like multiple choice. It'll be just it'll be based on the main concepts. Okay, how do we treat data? What's the process of statistics? Can you identify different data types? Can you identify a study? Just like
four?
Yeah, just like that. Actually, it'd be a lot like this, where you'll read a problem, and then I'll ask, the who is, and then I'll give you different choices, and you tell me the who in that context. Okay?
All right.
You can do the homework for seeing, and I'll post a solution set tonight because I haven't got everyone's homework. I'll post a solution set so you can check your answers. Okay?
Okay.
All right.
So
Other questions?
It is not a reason, right? So I think it's this one is the cluster sampling, which are the test all 40 players on the team.
Well, you were right. It was cluster sampling, but you have to explain why. Why is it cluster and not stratified?
Because I think that the test is.
I could do the same thing. Maybe I think my strata or the teams. I'm going to take a team and do everybody in the team, right? So why is that cluster and not stratified? What is the difference? Does that make sense?
Yes, it makes sense.
Because when we talked about this before, what did we say the difference was? The variation, right? So what do you think? Do you think that the teams are the groups, right? So do you think that the teams overall are roughly the same, and there's a lot of variation inside the team, or do you think that the teams are different And inside a team, either
In the same
everyone
area.
takes drugs or they don't take drugs, right?
Yes.
It's probably clustered, right?
Yes, right.
That's the reason why it's clustered. It's always variation. What do you believe? That the groups vary and inside the group it's homogeneous? Or do you believe that the groups are roughly the same, but inside the groups there's a lot of variation? It all has to do with where you think the variation is. And sometimes it's just your opinion. I mean, we check those assumptions, right? But we all have in our minds our little models of the way we think the world is. So when we design it, we have an idea in mind, but then we check it. And if we're wrong, we have to redo it again. All right?
All right. Thank you.
Sure, no problem. Questions?
这里只是 data 的哦，没有 graph 的。
Oh man, sorry.
保
I
存的时
thought
候
it was third.
没有，你只要抖这个点上就敲到了。
没有，
I know.
有。
你看
I think it's the unofficial seating chart. I'm sorry.
就是那个。